In this video, we're going to look at how to set up confidence interval for one population variance or standard deviation. So this is confidence interval for standard deviation. We've already looked at the formula. So this is the confidence interval for variance. But of course, when we take a square root, then we get the confidence interval for standard deviation. So we're going to look at an example from page 450. And that example is about a filling station that fills 16 ounces per container of some detergent product, liquid detergent product. And we want to develop a confidence interval for the variance in the amount filled in the containers. So in page 453, the problem further describes that we take a random sample of 20 containers and the sample variance turns out to be 0.0025. So 20 is the sample size, sample variance is 0.0025. Now let's return to Excel. Okay, sample size is 20, sample variance is 0.0025. Now the population is ounces of liquid detergent filled in the container. Sigma is the standard deviation of the ounces of liquid detergent filled in the containers. N is the sample size and S is the sample standard deviation, or S squared will be sample variance. Now given the sample size of 20 and sample variance of 0.0025, we want 95% confidence interval for variance. So enter 95%. Okay. So now we need chi-squared 1 minus alpha over 2 and chi-squared alpha over 2. So let's first set up alpha over 2. So 95% is 1 minus alpha. So 1 minus that will be alpha. And that divided by 2 will be our alpha over 2. Degrees of freedom is n minus 1. So we have the sample size n minus 1. Chi-squared dot inv function with alpha over 2 and degrees of freedom. Okay. This will give you, for cumulative probability of alpha over 2, the chi-squared value. In other words, the right side probability will be 1 minus alpha over 2. And for the right side, we use chi-squared dot inv dot rt and alpha over 2 comma degrees of freedom. So for the left side, we use just chi-squared dot inv. For the right side, we use chi-squared dot inv dot rt. Then confidence interval for variance is n minus 1 times sample variance. This is already sample variance, so there is no need to square this, divided by the larger chi-squared value, that is chi-squared of the right will give you the lower limit, and n minus 1 times S squared n minus 1 times S squared divided by chi-squared sum left will give you the upper limit. So these are the two limits for variance. You take a square root of that that would be the confidence interval for standard deviation. So we can say we are 95% confident that the population variance of ounces of liquid detergent filled by the machine will be between 0.0014 and 0.0053, and the standard deviation will be between 0.0380 and 0.0730. Let's justify, and that's the confidence interval for variance or standard deviation.